Let us study the chapter 10 for chemistry today. That is, states of matter, gaseous and liquid states. The three distinct physical forms of a substance are solid, liquid and gas. The table here shows distinguishing points between solids, liquids and gases. Intermolecular forces. Intermolecular forces are the attractive forces as well as repulsive forces present between the neighboring molecules. Types of intermolecular forces. The four types of intermolecular forces are dipole-dipole interactions, ion-dipole interactions, dipole-induced dipole interaction, hydrogen bonding, London dispersion forces. Take a look at the table for the comparison of intermolecular forces. Ion-dipole interaction, dipole-induced dipole, London dispersion and hydrogen bonding. Let us now see the characteristic properties of gases. Gases are lighter than solids and liquids, that is, possess lower density. Gases do not possess a fixed volume and shape. They occupy entire space available and take the shape of the container. Gas molecules are widely separated and are in continuous random motion. In case of gases, intermolecular forces are weakest. Gases possess the property of diffusion, which is a spontaneous, homogeneous intermixing of two or more gases. Gases are highly compressible. Measurable properties of gases. Some important measurable properties of gases are given below. Mass, volume, pressure, temperature, density, diffusion. Statement of Boyle's law. For a fixed mass, number of moles N of a gas at constant temperature, the pressure P of a gas is inversely proportional to the volume V of the gas. Or, at constant temperature, the pressure of fixed amount, that is, number of moles of a gas, varies inversely with its volume. Charles' law, temperature-volume relationship. At constant pressure, the volume of a fixed mass of a gas is directly proportional to its temperature in Kelvin. Gay-Lussac's law, pressure-temperature relationship. Statement: at constant volume, pressure P of a fixed amount of gas is directly proportional to its absolute temperature T. Avogadro's law. This gives the relation between volume and amount. It states that equal volumes of all gases at the same temperature and pressure contain equal number of molecules. Dalton's law of partial pressure. The total pressure of a mixture of two or more non-reactive gases is the sum of the partial pressures of the individual gases in the mixture. The table shows the difference between ideal gas and real gas. Liquid state. Liquid state is the intermediate state between solid and the gaseous state. Vapor pressure shows in the figure. Factors affecting vapor pressure, nature of the liquid and temperature. Surface tension. The force acting per unit perpendicular to the line drawn on the surface of a liquid is called surface tension. Application of surface tension. Cleaning action of soap and detergent is due to the lowering of interfacial tension between water and oily substances. Efficacy of toothpastes, mouthwashes and nasal drops is partly due to presence of substances having lower surface tension. Viscosity. Viscosity is the force of friction between the successive layers of a flowing liquid. It is also the resistance to the flow of a liquid. Lubricating oils are viscous liquids. Gradation of lubricating oils is done on the basis of viscosity. A good quality lubricating oil does not change its viscosity with increase or decrease in temperature. Increased blood viscosity than the normal value is taken as an indication of cardiovascular disease. Glass panes of old buildings are found to become thicker with time near the bottom. This is one evidence which indicate that glass is not a solid but a supercooled viscous liquid.